Okay, in the final lecture, we're going to talk about some practical guidelines. So here's some of the hyperparameters we have to choose, like the initialization logic, the activation function, etc. So the practical guidelines I suggest here are taken from Geron's book, and he suggests LeCun initialization for the initialization logic, along with the Celu activation function. And as you can maybe recall, this means that if we have a neural network which is fully connected and sequential, then we have the self-normalizing taking place, which solves the vanishing gradient problem. And we set the normalization to none because of this self-normalization. And the regularizer, we can actually just use early stopping. This is sufficient. Optimizer, we talked about NADM, which is the Nesterov trick applied to Adam. So this is a practical starting point for any deep neural network you're going to be working with. And remember, it's good practice to start with a few layers and a few neurons, and then slowly increase and adjust both until you find good convergence. Eventually, you'll build up a good feel of how many neurons and how many layers you'll need. Always standardize your input features. This is, of course, a condition for the self-normalizing. If you start to overfit, dropout or Monte Carlo dropout. In particular, if you don't need extremely fast computation at test time for the Monte Carlo dropout. If you have a custom model that cannot self-normalize, consider using exponential linear unit instead of the scaled exponential linear unit. And if possible, batch normalization. Okay, now the most exciting part, the final course project. So we're building a deep neural network using all the lessons used so far to predict if a consumer will default on their credit card loan. We will not only be using tools learned in this course, but we're actually going to expand a little bit on ideas such as Monte Carlo dropout and how we can adjust risk and make it slightly safer for us on the credit card loan side. So we're not only going to be making high quality predictions as to if someone's going to default, we're also going to be putting the risk in our favor. So imagine you're a research scientist at a Taiwanese startup called Lakeside Loans. You receive a request from your manager in the form of a letter. So please download and read the letter to begin with, and then watch the follow-up video, which will explain your task in a bit more depth and go through the workbook. This will give you some context and understanding as to what you'll be doing. Good luck. But before, let's just complete the quiz. Here's the summary slide from 2 slides back. Try to recall what is the reason that we're using this particular LeCun initialization with the Celu activation function, and why is this useful for deep neural networks? I'll give you a minute to think about it. Okay, here's the answer. So this structure, as described in the 2017 paper by Klambauer, says that we can solve the gradient exploding vanishing problem for a fully connected sequential neural network, which means that we don't have to have any default for this normalization if we're using this. But remember, this comes with some terms and conditions, so to speak, such as we need standardized inputs and also this fully connected sequential model. Okay, thank you.